Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CIPAT, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in computer science. In today's session, we will be seeing about the concept of operator overloading in C++. We have already had an introduction into operator overloading in the previous session. So, we will be seeing about the prefix and postfix operator overloading in unary operators, the binary operator overloading and the concept of dynamic polymorphism. Prefix operator overloading. So, prefix means it comes before the operand and postfix means it comes after the operand. So, in prefix operator overloading it resembles like this: the operator comes before the operand, either plus plus and then the operand or minus minus and then the operand. In prefix and postfix, normally we have only increment and decrement operators, that is, they do the work of either increasing the value of the operand by 1 or decreasing the value of the operand by 1. Similarly, in postfix the operator comes behind the operand. So, this also we have increment and decrement. This will increment the value of the operand by 1 and minus minus decrements. Now, the operator function, we have already seen what is an operator function, the function which defines the extra work that an operator should do. That operator function which does not have an argument is taken by the compiler to be the function for a prefix operator, because see, there has to be some way the compiler should differentiate between a prefix and a postfix function. So, if the operator function is not having an argument, the compiler takes it to be a prefix operator function, and if the operator is having an argument, then the compiler takes it to be a function for the postfix operator. So, we will see using an example program how the two functions are invoked by the compiler. Again, you are having a class called over, you are having one data member which is of private type and is an integer variable. You are having two constructors in the public section of the class. One constructor is not having any argument, the other constructor is having an argument. So, this is only the concept of constructor overloading, two constructors with the same name as the class, but they differ in the parameters they carry. And then you have defined two operator functions in this class. Both are increment operators, one is not having any argument. Now, here if you see, there is no argument for this function, it is empty. The next is having one argument of type integer, but both are operator functions of the operator plus plus. So, this is only called operator overloading function. Everything is same except the number of parameters, one is not having an argument, the other is having an integer argument. That is only called operator overloading. Then you have a function called show, that is, we all know, to display the result. So, the functions have been declared over here. Now, we have to define each of these functions. So, you are defining the first constructor, you know it is only to initialize the value of the members. There is only one data member of type integer, that is n. So, initializing its value to 0. Then you have another constructor with one argument. This argument will be given from the main function and you are initializing the value of the data member to that particular value. So, the work of the two constructors, the initialization job is done. Next, we have to define the function for these operators. So, we all know that the increment operator increases the value of the operand by 1. Now, this function is for the prefix operator. We know that a prefix operator first increases the value of the variable and then only displays the result. So, in this operator function, you have to make use of a temporary variable. The temporary variable should be an object. So, how are we going to create an object? Class name followed by object name. So, that is what is done over here, class name followed by this object t. So, the variable or the operand which has to be increased in its value is associated with this particular object t. So, what are we doing over here? This is the data member of the class. We are increasing the value of this member by 1 because this is a increment function. Then we are assigning this value to this temporary object and then we are returning this object to the main function or the function which called it. So, we have to remember that the operator functions are declared and defined with respect to classes, but they are called from the main function using an object. So, when they are called from the main function, this particular data member is associated with that object. So, we have to increase the value of the number and we have to assign that value to the object, and then we have to return that object's value. So, that is what is done over here. Here we are returning the object, return t. T is nothing but an object. That is why the return type is also here of type class, because an object belongs to a class type. So, these are the things that are to be kept in mind when we are overloading an operator and defining an operator function. Now, here we have defined the operator function for the prefix operator. Next, we have to move to the postfix operator function. So, here because there is one argument, the compiler takes it to be of type postfix. Here also you have to return an object only, the return type is of type class. So, here you are declaring a temporary variable t. Now, in postfix the difference is, first the operand is value is taken or it is used, afterwards only its value is incremented. So, this is different from the prefix. In prefix first you increase the value and then you manipulate the operand. Here you manipulate the operand or you do the work with the operand and then only you increase its value. So, here the operand as such, as it exists, is assigned to the temporary variable. Afterwards you are increasing the value of the data member by 1. So, you are saving the previous value of the operand in the object, then you are increasing the value of the operand by 1, but you are returning the value of the object only. That means the unchanged result only you are returning to the function. So, how do the results of these two operator functions differ? We will see it when the compiler invokes the main function. So, now the operators all have been defined, we still have to display the show function. Now, here you are having the display function. Display does nothing but it prints the value on the screen. So, cout number is n, it prints the value of the data member in the class. Now, here from this main function only the execution of the class begins. So, first you are creating the first object over O1. We know that as soon as an object is created, the compiler will call the constructor. Here there is an object with no argument, here there is an object with one argument. So, when the compiler sees this, it will call this particular constructor, initialize the first object's data member to 0, the second object's data member to whatever number was passed over here. So, O1 will have the value 0 for n and O2 will have the value 10 for n. Now, this is how the compiler calls the operator function. O2 is equal to O1 plus plus. Now, here if you see the plus plus is coming after O1. So, when the operator comes after the operand, it resembles a postfix operator function. So, this particular statement will call the postfix operator. So, when the postfix operator is called, what action is taken by the compiler? It will go to this postfix expression function, plus plus with an integer argument. So, what it will do? It will create the object, it will assign the value of that object to this, of the data member to the object, it will increment the value of the operand by 1, it will return the object. So, the actual value is only returned to the function. So, this O2 will now carry the value 10 only, it will not carry any extra value because it is a postfix expression. First the value of the argument is incremented and then only the value will be given to the manipulation in the case of postfix. So, the operator comes after the operand. So, first the operand is used up and then the value of the operand is incremented. Then what are we having in the next statement? We are having this O1.show and O2.show. Show is nothing but to display the result. Now, this O1 is nothing but it is having the value of n as 0. O2.show is having the value of 10 or 100, it is only given as an example. So, you can just assume that O2 is having the value 10 or 100 and you can display the result. Next statement is O2 is equal to plus plus O1. So, here if you see the operator is coming before the operand. So, in this case a compiler will take it to be a prefix operator function and it will go to the prefix operator, the one which is not having any argument. So, here you are going to increase the number by 1, assign it to the object and return the object. So, first if you see you are having the same value, then the incremented value and then the prefix operator increments the value twice. So, once again you are having O1.show and O2.show. So, this is how the output will look. First you are having the value of 10 incremented by 1, then the same value, then 102 and 102. This is because the value of that variable is incremented. When it is prefix, it is incremented twice and it is displayed. So, this is how the compiler invokes the operator function and it displays the result. Next we move over to binary operator overloading. In binary operators we know you need to have two operands. So, you can have plus, minus, multiplication or division. You can overload all these operators and you need to have two. In the previous program that we had seen, there was only one object and one operator, O1 plus plus or O2 plus plus, plus plus O2, prefix or postfix. Here it is binary, so there needs to be two operands. So, in which case two objects have to be involved in calling these operators. So, this is similar to overloading a unary operator, except that it requires a binary operator, that is additional object as a argument. So, we will see an example for this as well. You have the over class, you are having a private data member, you are having n of type integer, the same program I have used that we had used for the unary operator, but the thing is here we are going to have two objects, the same two types of constructors, one with an argument, one without an argument. And here if you see the definition of the operator function, the declaration itself is different. There it was over operator plus plus with an argument, without an argument. Here it is a binary operator. So, I have just given 1 plus the operator function of type class and I have here passed an object as a parameter. In the prefix and postfix operator overloading, you had seen that we had passed a variable, integer variable as an argument, whereas in this binary operator overloading, we are passing a object of the class as a argument. So, this is the difference between unary and binary operator overloading. Next, we are again having the display function to display the result. So, how does the compiler identify this operator overloading and how does it call the function? So, before we go to the main function, we have to first define the constructors and this operator function in the class. So, you are having the first constructor function initialization to 0 and the next constructor function where you are initializing the data member to the number variable, and then you are having this operator function, return type is of type object, class name, scope resolution operator, operator keyword, the symbol and then over OB. This over OB is explicitly given over here only to identify the parameter as an object. And inside this particular definition, the same thing that is coming for unary operators, we have to have a temporary variable which is of type class, that means this is also an object. Now, this is where the difference lies between the unary and the binary operators. In the case of the unary operator, you simply had one operand over here and you either increased its value and assigned it to this object or you assigned the same value to the object. In the case of binary operator overloading, if you see, you are having one temporary object T, you are having the data member as such and you are having an object plus the data member. So, what does this indicate to the compiler and how it is interpreted by the compiler and how do we understand that it works? We will see this after the break. Welcome back after the break. So, we had been seeing about binary operator overloading in C++. So, we have seen the definition of the class and the definition of the constructors. Now, we are seeing about the operator function. In binary operator overloading, we all know binary operators take up two operands. So, when we come to operator overloading, our operands are nothing but objects. So, objects are nothing but they belong to a class. So, when you are overloading these binary operators and you are defining the function of what the operator is expected to do, you need to have two objects whose values are to be added and you need a third object where the added value is to be deposited. So, that is what is done here in this operator function. You are having the third object which is supposed to hold the value, the added value. You are having one data member which belongs to the object which calls this function, and you are having the second object whose value you are passing as an argument. So, three objects are involved over here, one object which calls the function, the other object which is passed as a parameter to the function, and the third object which is used to hold the added value or the manipulated value. And finally, you are returning the object which has been manipulated. So, this is how binary operator overloading works. Now, in case instead of addition, if it was subtraction, here instead of plus it is going to be minus. If it was multiplication, it is going to be a multiplication symbol. So, all the operators are to be overloaded the same way. The only difference is the change of symbol. The syntax, everything else is the same. The way the compiler understands the particular function also is the same. So, this is just an example where instead of addition you can use it for any other arithmetic assignment operators. Next, we are having this display function show, where you are just displaying the number. Then you are having the main function. Now, here is where the compiler actually starts reading the program. So, this is where the execution of the program is going to start. So, first in any C++ program, as soon as the main function is created, we first have to create objects, because only using the objects you can access the members of the class. So, here I am having first object is O1, which is having the value 10, second object is O2, which is having the value 20, and the third object is O3. Now, here if you see, there are two constructors, one with no argument and one with an argument. Here if you see, there are two objects with an argument and one object without an argument. So, as soon as these objects are created, in both the cases the compiler calls the constructor which is having one argument. So, we will see which is that constructor, over int num. So, in the case of O1, 10 is assigned to n, in the case of O2, 20 will be assigned to n. So, whatever value is passed over here, that is assigned to the data member. Now, the next step we are having O3 is equal to O1 plus O2. So, this is how the operator function is called in C++, O1 plus O2. This is nothing but a binary operator plus, two objects are being sent as parameters, the third object is receiving the result. So, this O3 is receiving the result, O1 is calling the function, O2 is being passed as a parameter. So, how does the compiler understand or execute this particular function? It will go to this binary operator function where this first n is taken as O1's n, this OB dot n is taken as the n of O2, this OB is understood as the object O2, and this T is understood as the object O3. So, now O3 is mentioned because it has to hold the result. So, that is assigned to this temporary variable. One object is passed as a parameter, that is a second operand, and this n belongs to the object which called the function, that is nothing but O1. So, O1's n is having the value 10, O2's n is having the value 20. So, 10 plus 20 is nothing but 30, that is assigned to this particular object T. Finally, you are returning the value of T. So, this is how the compiler understands this overloaded function, and then it will return the value T to this particular statement. The value T will go to O3, which is nothing but it holds the value 30. So, after that you are having this O1 dot show, which will carry the number 10, because O1 has not been manipulated, only O3 is changed. O3 is only holding the result. O1 is having this value 10, O2 is having the value 20, only O3 is having the value 30. So, when you give O1 dot show, the previous number 10 is only displayed. When you give O2 dot show, the number 20 is displayed, and when you give O3 dot show, the added operator function or the added operand value 30 is displayed. So, this is how a binary operator is overloaded in C++. Now, this O3 is equal to O1 plus O2, that particular statement is only the climax of this entire program, because depending upon the objects that are involved in that particular statement only, the compiler will interpret the operator function. So, that is a way you have to understand that particular statement. The plus operators used to overload or add to objects of the over class. So, you are going to add only objects here. O1 is the object of which the operator is a function, that means O1 is the object which is calling the operator function. O2 is the object which is passed as the parameter, and while overloading binary operators, the object on the left side of the operator is a member and the object on the right side is a parameter. So, you might have thought O3 is equal to, so I will just explain it with this particular operator. O3 is equal to O1 plus O2 was the statement, and according to the rule, the object on the left side of the operator is the object which is calling the function. the object on the right side of the operator is being passed as the argument. So, if you give O2 plus O1 also, it does not make any difference, because in the case of addition you are just going to add the two values, but when you are going to divide or when you are going to subtract, this order becomes very important, because you have to always subtract the lower from the higher, mostly that is the case, unless you want a negative result. So, this particular order you might think in the case of addition it does not make any difference, even if you give O2 plus O1 it is going to add 20 plus 10, and if you give O1 plus O2 it is going to add 10 plus 20. This is okay in the case of multiplication and addition, but in the case of modulo division, in the case of subtraction and in the case of division, this order becomes important. Which number you are going to divide by which number and which number you are going to subtract from which number. So, for that you need to understand the rule and the order. O1 is the object which is calling the function, and O2 is only passed as the argument. So, the object on the right side is passed as an argument, object on the left side is passed as the first parameter. So, this is the way the compiler understands the operator function. So, we have to think like the compiler when we execute the program. So, only when we think like the compiler we will know how the program will execute and how we will get the result. So, this is how binary operators are overloaded in C++. So, next we move over to the concept of dynamic polymorphism. So, static polymorphism is nothing but implemented using this overloading concept. We have seen about function overloading and operator overloading. Next we move over to dynamic polymorphism. A function is said to exhibit dynamic polymorphism when it exists in more than one form. That is, the same function exhibits different forms at different times based on some situation in the programming paradigm, based on some result of the programming paradigm. The compiler associates a function with a class by identifying the type of object or pointer. We have seen using pointers how to call functions. So, it associates one function with a class based on the type of object or the pointer that calls the function. Invoking the function means calling the function. And the process of associating a function with an object is only called binding. So, this term binding is highly important when we are executing a program, because the compiler needs to know which object is calling which function, only then it can return the result of the function to that object. In the previous program we saw O3, the result of that added value has to come back to O3. For that reason the compiler should know that that statement only called that particular function, otherwise where will that result go? We will not be able to see the result. So, that binding concept is the main thing in execution of the program. The compiler should associate the function with the object, and that process is called binding. Binding of a function to a class at execution time, runtime is nothing but execution time, that is called late binding. Normally during compilation itself, the compiler will understand that this function is called by this class or this function is associated with this object. Normally while it is compiling the program itself, it should identify. That is the normal static binding. But if it is going to bind only during the execution of the program, that is called late binding or dynamic binding. Like you have dynamic memory allocation, like that dynamic binding. And dynamic polymorphism is normally implemented using virtual functions. Virtual function is a concept which we will have to study after we study about inheritance. So, we will see an example why virtual functions are required to implement this dynamic polymorphism. Say you have an employee class. This is called the base class. It is having a function called calculate. Base class is the class from which other classes inherit. We have already seen the definition of inheritance. Say you are having another class called trainee and a class called manager. Both these classes are inheriting from the employee class. That means they are called derived classes or subclasses. Both are having the same function, calculate again. So, when they inherit itself, they inherit the calculate function. In addition to that, they are having their own definition of this calculate function. So, in this case only we have to identify the concept of dynamic polymorphism. The same function calculate is exhibiting different forms in different classes, though the classes are related to each other by inheritance. So, this is just a skeletal picture of the program. Class EMP with a calculate function, you are closing the class. Class trainee, public EMP is nothing but the syntax for inheriting. This is having the same function calculate with its own definition. Then you have class manager, again inheriting from EMP with the same function calculate. So, how does a compiler know when you create an object with which class it should call the calculate function. So, that is where dynamic polymorphism comes into picture. You are having the main function, you are having the creation of a simple object and a pointer object. This pointer is called the base pointer because this is the pointer for the base class or the super class. So, that is called the base pointer. E1 dot calculate, the normal way of calling the calculate function. So, this will call the calculate of the main class. We have to use the new operator with the pointer. So, you are creating an object for the trainee class, you are calling the calculate function, creating an object for the manager class and calling the calculate function. So, what you will understand from this, you will be of the opinion that because you are creating the pointer for the trainee class, this calculate will go to the trainee calculate, and here because you are creating the object for the manager class, this will go to the manager calculate, but that is not the case. In the case of inheritance, because both of them are subclasses for this employee class, the compiler will not take them as different classes. There is a big relationship involved in that. So, simply by using base pointers, you cannot implement dynamic polymorphism. That is why you need virtual functions. So, before you understand dynamic polymorphism, you have to know about inheritance, and then we introduce the concept of virtual functions. So, static polymorphism is easily implemented using overloading. But to implement dynamic polymorphism, you need the concept of virtual functions. Pointers are a must, but they are not sufficient to implement dynamic polymorphism. So, this is where the need for virtual functions comes into picture. So, we will see about the concept of virtual functions and inheritance in the forthcoming sessions. So, in today's session we have seen about prefix and postfix operator overloading, the concept of overloading binary operators, and dynamic polymorphism, definition of late binding, and why virtual functions are needed to implement this concept. How does the compiler differentiate between prefix and postfix expressions? It is using the arguments. In the case of a prefix operator function, it will not have an argument. In the case of postfix, it should have an argument, preferably an integer. An operator function is the user defined function which actually tells what extra work that particular operator should be doing. Dynamic binding is a concept of associating a function with an object or a class during execution or runtime. The pointer which is created for the base class or the super class is called the base class pointer. And the syntax for a binary operator function, you know, it is a return type which is nothing but a type class, class name, scope resolution operator, the operator keyword, followed by whichever binary operator you are overloading and the set of arguments. So, this is the syntax for binary operator function. For any operator, that is the syntax, only the symbol of the operator will differ. So, these are the concepts which we have seen today. The dynamic polymorphism, inheritance and virtual functions we will see in the next session. Thank you.